Hey, how's it going? So I guess should we just start off with just talking about the project a little bit and just letting everyone know what like the 3D blockchain is, and just yeah, start off there maybe before we go right into the questions.
Okay, so a little, I guess, brief on the three-dimensional chain. That's basically designed as a check and balancing system and also a multi-dimensional scaling solution. So what that means is generally a blockchain is a single dimensional structure. I usually like to use the analogy of it being kind of like a single line. And what the multidimensional chain is allowing is it's allowing it to kind of form into a grid that can expand out in widthwise as well as longwise to create parallel processing channels, so that essentially as more nodes come to the network, it's able to handle a higher capacity. So in computer science terms, this is called something linear scaling. And what that allows it to do is it basically removes any arbitrary limits on transaction capacity, and it makes it, I guess you can say it removes software bottlenecks and it puts that closer to hardware. So the requiring of the hardware is basically what limits the network's throughput rather than an arbitrary number like a block size. And this also, it incorporates multiple checking and balancing where you have the level 1 and level 2 and level 3 locks, where the level 1s are, I guess you can say, a higher risk of validation. Level 2 is reduces that to finally get to level 3. Each one has its own weighting system associated with it to prevent Sybil attacks. And it also incorporates the best of all the worlds, including kind of a proof of stake and mining, and I guess you could say it a Byzantine fault tolerance with a weight of, let's call it a simple prime number, or the trust as well. So you combine those three together so that each doesn't really need one another, but they complement one another, so that the security of our network won't rely completely on the mining power, and it won't rely completely on honest proof of stake nodes addressing the nothing at stake issue. And it will also allow parallel processing on the level 1s without breaking a global consensus mechanism. So all of those put together, it's projected to be a solution that resolves a lot of the current limitations we're seeing in the architecture of a blockchain, which essentially is a distributed database. So we're kind of taking that, I guess you can say, to the next level. A lot of it was formulated just from studying Satoshi Nakamoto's original code and work and learning to think the way that Satoshi thought, and also seeing things that Satoshi may not have seen coming as far as constraints in the development and scaling of it, and kind of continuing the work forward.
Cool. There's a couple questions that we just got in about the three-dimensional blockchain. One of them was, how does it differ from the Lightning Network on scalability? And also another one was, how does it differ from our chain's solution?
Well, our chain is doing pi calculus is what it's called. So that's kind of doing more parallel processing on the contracting levels. We have a different approach to doing it. I can't give all the details at this moment, but it differs on that way. We're talking about the ledger. So our chain, it looks like they're looking at kind of parallel blockchains, and I haven't done an incredible amount of research on it, but from some of the basics that I've seen, it seems like it could have some challenges getting the ledger level to work. Pi calculus is definitely a really cool solution, though relying completely on all the processing being done on, I guess you could call it the core protocol level, can still come with some constraints. As far as the difference with Lightning Network is an off-chain solution. So that means that the state of all of the, you could call them payment channels, is going to have to be recorded on some sort of internal database system, so that when it settles back on the blockchain, you can have a decent record of who sent Bitcoins where, and it's going to have to open more channels. Now, there is postulation that it could degrade into hub type environments in order to provide liquidity for the channels to transmit through. So I generally believe anyway that everything should be done on the ledger level, and that way you can have it fully immutable. There could be some unforeseen challenges in the Lightning Network just basically doing a messaging system between the two and then having to have your own internal accounting done on it.
Okay, it looks like a lot of the questions are about the hardware. People are really interested in the satellites. And could you tell us a little about just how it all works in the infrastructure?
Yeah, so the idea is that we want to help kind of bridge the access to the internet. Right now, it's mainly, I think a couple billion people that are able to access it. And the cost to continue to build it out with copper and fiber is incredibly high. Seeing like a simple number is it can cost up to 300 million to run one cable from the United States to Europe, and those are generally controlled by governmental entities. Our idea is to leverage this new cube satellite technology to allow intercontinental relays and doing as much on the ground as possible through the mesh network, so that it gets the emphasis of it is that you buy a piece of hardware, connect your phone, create the ground-based mesh networks, have incentives to run ground stations, and the mesh networks can talk to one another, which builds the foundations of a more distributed, decentralized internet, where the actual hardware that runs it is owned by the people that use it, rather than the ISPs that then can do pretty much whatever they decide to do with it. Usually it's charging fees, sometimes it's blocking certain websites, other times it's monitoring your web traffic. So those are some of the basic hardware levels. We see it, the software is designed to be decentralized and distributed, but the internet isn't always that way. So we kind of are mirroring the software with the hardware and developing that out so that we can have a more truly democratized distributed system built in over time.
That is awesome. I really like mesh networks a lot. Mesh technology, I think it's awesome. I used it when I was in Afghanistan, where they didn't have internet connection, and it worked. But will this work in areas that are more remote? How many satellites are you going to launch? And people want to also know how expensive they are, and who are you partnered with to start building these things and getting them up?
So basically, satellites, depending on the complexity of it, they can be anywhere from $50,000 to $100,000. So divide that into 300 million for the cost of one cable. The amount of satellite coverage we could get for the cost of just conventional infrastructure is extremely high. So I wouldn't say necessarily that we want to have a limit on it. These cube satellites too, depending on the orbit, they can, last anywhere from 5 to 10 years. We're designing it to be kind of a constellation that's constantly changing and being upgraded. So we're developing an incentive system into that so that it gives people a reason to do it. There's something that people can relate to. Part of that can be with the mesh networks. And so one of the ways, and there's also other constellations that we're partnered, one of which is Vector Space Systems. They've created, or are creating, I should say, what's called Galactic Sky, which is a software-defined satellite system. An analogy would be kind of like AWS in space, where people can start experimenting with space-based computing. So we're going to have direct access to that constellation, and the constellation we're deploying in parallel, we're designing to have forms of interoperability where they can almost be liaisons or connections between other types of constellations. So we create kind of a collaborative space-based mesh network that can provide greater ground coverage, more bandwidth, more availability, and then obviously the ground-based mesh networks to handle most of the transmission if needed. But if you are in a remote rural area and there's, let's say, a sparse mesh network and there's very limited connectivity, the satellite would be the choice to go to in order to get your signal to another one. And the idea is that as these mesh networks get bigger and bigger, they rely less and less on the satellite mesh for intercontinental relaying if they have, let's say, most of them localized calls or data transmissions. So that's the idea, and is, satellite engineers, our satellite engineer, his philosophy is do as much on the ground as possible and use the satellites for what they're really truly useful for too. And one of the core things that we've seen is accessibility to the connection to the network, even if you are in a rural area.
That's awesome. Big Red Riding Hood wants to know, once the satellite's set up, how will Nexus be viewed? He's wondering about search engines, websites, etc. Can anyone set up their own site, for instance, mettube.nexus, we've seen broad strokes on what Nexus can do. I'd like to see them paint more details on this and how it will work for an average person.
Well, for the average person, it would start out with, I mean, obviously this is going to take time for these mesh networks and the constellation to mature. So, I mean, we're going to rely on some of the conventional infrastructure, but the idea is that as it gets bigger, you're going to need it less and less. So what it would start to look like in the future is people will be able to start having ground stations and maybe create their kind of localized access points in their local mesh network and give people access to their antenna for, let's say, a fee that they charge, which would make it a more peer-to-peer system. And, you know, they want to make money or ROI on their hardware. You create that incentive into it and the people will just build it. And that, in my opinion, makes something really powerful because it's owned by everybody and is created by everybody instead of one singular entity or a few singular entities. So as far as the internet protocol that we are conventionally using now, and it would still be able to connect through to the old internet, depending on if somebody wanted to provide, let's say, their internet service as a gateway to the old internet. But eventually, I mean, it could be something as simple as running servers or whatever else, and those servers would just be connected to this new mesh so that, you know, if you didn't have a route on the old network, you could use these new networks to do it. And I mean, if you wanted to completely not use the old, you could if you have those routes. So I see it as being similar to how we see the internet now, but it's going to create a more localized, I guess, independence. And, you know, the reduction of ISP bills and potential censorship is one of the highlights that we're really looking for because it creates collective authority with people and they choose what they really would want, maybe regionally or globally or anything like that.
Okay, it looks like Anastasia has a long list of questions here. I think we touched on a couple of them, but were you guys an ICO? And if you were, was that money basically for hardware or how did that all work?
So we were never an ICO. We came around way before the days of ICOs. The network Genesis block was mined on September 23rd, 2014. So we have a kind of, I guess you could call it a treasury system built into the protocol. So that allows this to remain sovereign, the funding to be generated in real time, but without having to have, let's say, I own all these tokens and I sell them a piece of you and I keep a certain amount for myself, like, which is a conventional type of ICO. The embassy or the nonprofit that we use now owns a very small amount of the total Nexus. And it didn't rely on a distribution method of selling tokens for them to be distributed. It's actually mined into existence and it's staked into existence as well at a variable interest rate. That starts to get into the trust system a little bit, where it's kind of proof of time, where we're utilizing time as a security method, but also, I guess you can say, is a way for the network to measure itself against itself. Because if there's no way for something to know itself, then it can't know what's foreign to it and trying to attack it. So building this type of trust system, it creates, I guess you could call it a circle of trust of things, and people build that up with one another. And if, let's say, a bad actor comes in, it's easily detectable because you have a normal state that you can compare that to, kind of like the immune system on the body of the human works.
Okay, and how does the integration of Lisp help Nexus achieve its goals?
So conventional cryptocurrencies, they utilize the transport control protocol. People know it as TCP/IP. That's up in the layer 4, layer 5s, and then the application layer sits on layer 6, layer 7. Lisp is down low on layer 3 to layer 4, somewhere in the middle of them. Dino likes to call it layer 3.5. But the idea with Lisp is its location identifier separation protocol. So let's say that I have a unique internet protocol address, right? It could be tied to a trust key, it could not. However we want to configure it, and somebody would be able to make a connection to you, but my connection, let's say, may not be available on the old internet, or it may not be available on the new internet, or it may be through a mesh network, or it may be even because you're close enough to me and we can Wi-Fi between each other. Those would be called roaming or routing locators. So what it essentially does is when you go to make a connection to an EID, which is an endpoint ID, which would be your fixed ID, kind of like having the same telephone number, you'll be able to roam between many different networks, whether that's the LTE, whether that's the old internet, whether that's Wi-Fi to Wi-Fi, or whether that's on a mesh network, or whether that's a satellite. And there's always going to be a way to connect with you, no matter what network you're on. So that acts as a really unique bridge for the decentralized internet aspect. But then the other really cool part about it is that it allows us to create scaling solutions with IP multicast, where the packet replication is done on the lower levels of the networking stack. And so we're kind of aiming to utilize that in a way so that you don't have routing that takes a long time. I mean, every time a block goes through Bitcoin, it has to hop from node to node to node. And it's an exponential time, which means it's n squared. So it continually gets slower and slower and slower the more nodes get on. But with the L1 locks kind of segueing back to the three-dimensional chain, them being parallel processing channels on the ledger, there'll also be parallel processing channels on the actual network layers, so that we can take advantage of the speed and efficiency of these lower levels on the stack to kind of take everything into account and get as close to the copper and the fiber as possible to utilize it as full as possible. Because the higher up you get on the stack, the more processing is going into everything you're doing in the application layer. So cutting out as much as possible to make it operate as fast as possible is part of the goal as well.
Big Kid wants to know if you're going to have a iOS wallet and how would staking work from that.
So in the Tritium protocol, yes, we're figuring out our game plan on the iOS wallet. We've had some development so far. We're bringing some more iOS in-house. Staking would work similar to how it would work on your computer. You just have to have a recent state of your, let's say, transaction history, and you'd have to have a recent state of the blockchain so that you can create a block. Since the Nexus proof of staking system has an energy efficiency threshold in there, and that's part of how the weight works, it's very, very power, I guess it doesn't consume a lot of power is a proper word. So it would basically operate on the background in your application. And you'd be able to stake it just away, but you wouldn't need to hold the whole blockchain on there. And that's part of the Tritium protocol and the trust system that's going to lay a foundation for that. Is you'll be able to know the reliability of data on more points than just mathematically verifying things to that point. You'll be able to know the reliability of other nodes through the reputation and through your personal relationship with them based upon that reputation. And so that way a mobile device would be able to discern what is reliable and not, but not require it to hold gigabytes and gigabytes of blockchain data, which really makes it difficult to have an effective iOS wallet.
Okay, and someone wants to know, will Nexus be a free phone service?
I don't necessarily know if I can claim. I mean, one of the ideas is having Trust Chat, which is routed through the Nexus network. So, I mean, you could theoretically have a more secure version of voice over IP. If there's, let's say, your local mesh network is fairly cool and they don't really get down on you on cost, then yeah, you could most likely have some free type of internet service or phone service through that. The difficulty with that is there's always the hardware that needs to be created in order for the software to run on it, like a phone. So figuring out how that would be designed would be part of it. Also figuring out if is it an international or it's a localized call. I mean, there's a lot of different factors on there. So, I mean, ideally that would be wonderful if you could figure something out to make that possible. But as for it is right now, with all the circumstances, I'm not necessarily sure if I'd be willing to make that claim.
Also, how important do you think quantum resistance is as far as this coin is concerned, and why don't more coins use it?
Quantum resistance is something I've at least been speaking about since 2014 when I started noticing NSA and everything building up quantum computers. So I think the quantum attack, the quantum threat, I mean, I think it's a big thing of the reputability of a system. If a quantum computer goes out and starts stealing funds from people, it could be a big problem and create a lot of chaos and destroy a lot of credibility in the security of a blockchain. So that's something we put emphasis on. And you have to be forward thinking when it comes to cryptography, thinking hundreds of years ahead, at least if you can, making things designed to be able to handle that anyway, to consider it relatively secure. So that's one reason our key sizes are upgraded. We're using the highest grade cryptography that we found was possible at the time, 2014, and using some other unique programmatic ways to make it extremely, extremely unlikely that a quantum computer would have any impact nor threat on Nexus.
Yeah, I probably should have asked this first, but can you tell us about your background, like your personal background? Like, I know that you work with your dad, right, on some of this stuff, who kind of he works with like different, maybe the partnership you have with the place making your satellites, but if you could elaborate on that.
I guess from a personal background, I've always been somebody that's been very interested in computers. Pulled them apart when I was a child, started programming when I was about 11, got really into it. And then, always was fascinated with physics and engineering and building things. That eventually led me to an internship when I was 16, working for John Garvey, who is basically the chief operating officer of Vector Space Systems now. His company was acquired by Vector, using a lot of their knowledge and research they've had over 16 years. So that's kind of where the connection segues in. Vector Space Systems is a small satellite launching company, and they're also deploying their own satellite constellation, as I was stating earlier, about software-defined satellites, space-based computing. So the combination of those things gives us a unique positioning on getting a constellation rapidly deployed, based on Vector's rapid deployment of the rockets, and also having access to constellations that are being created and experimenting with the constellations we're creating as well.
Cool. So let's see here, what's a good one? How do you aim to lower the barriers of entry? Crypto is complicated for the average user.
So Tritium is one step forward in that. One of which is, having light protocol, so you don't have to worry about the synchronization process as much, if that's your choice. Another one is making it as seamless to, I guess you could say, a banking system that more people are generally used to. One of which is having a type of username, password, PIN combination built into the cryptography of your signature chain. So it acts as kind of a distributed login system. So it feels more like what people are used to, and it allows them to transact. And then another one is not having the limitations scaling, which has caused a lot of people to end up waiting days for their Bitcoins or end up spending $20, $30 for a transaction. So those are a couple areas that we're looking at. Also the user interface is a huge thing. Making, as my friend Ernie says, the grandma just button, where you have a button and most people don't really care about everything that's going on below it, but making it as easy to interface with it, where it's just as simple as type in your username and password, and push a button to create an address, and push a button to send once you've received funds.
Okay, and what are other features of Tritium? Can you elaborate on what else it does aside from being a wallet?
Well, Tritium's not just a wallet, it's actually a consensus update too, if we want to get under the back end nitty gritties. What it's doing is it's amplifying and augmenting the trust system with a new set of algorithms. It's creating level 1 locks on the protocol level rather than ledger level to simulate the different parallel processing channels without requiring consensus updates. It's also releasing the signature chain algorithm, which is another step to quantum security, and kind of a distributed identity system or a series of events associated with you so that you can own certain things associated with that. And then on top of that, advanced contracts, which are designed to make the integration of the use of smart contracts in a more grounded, easy to integrate way so that businesses can start taking advantage of it, whether that's in copyrights or transferring ownership of different pieces of data, or even, level 1 type of, autonomous organizations, fundraising, taking a lot of these things to the next level and finding the most useful aspects of blockchain and applying more utility than just a currency.
Right. One question I want to know is, where do you see Nexus going in the next, like, 1 year, 3 years, 5 years? Like, where's the vision with Nexus? How do you, because obviously a lot of coins in the communities want like a moon next week or mass adoption in a month. Like, where do you see the logical timescale going?
So over the next 3 years, we're deploying what's called the Tau framework, integrated to it the lower level library. I could get into those details a little later, but the Tau is a set of 3 major consensus updates, transitioning a single dimensional blockchain into kind of a multi-dimensional grid. So the first step is Tritium, the second step would be Amin, and the third step Obsidian. So the plan is to have them rolled out over the next 3 years in an optimum situation. Now, each one of them is designed to feature in a new set of the 3-dimensional chain, multi-dimensional chain, and to unlock new advanced contracting features, and also to take in requests of community features that may require consensus updates. So I see an incredible amount of development happening. I also see more nonprofits kind of popping up around, I guess you could say, the world in different countries, like Nexus embassies, if you want to call them, so that it continues to be distributed further and further. I also see some of the foundations of the distributed autonomous community forming, namely on the Obsidian update and the distributed mining pool acting in that way too. So ultimately, I see a wealth of many new technologies, and of course, satellite launches, testing that out, proving more uses of it, building more of the ground-based hardware. So there's definitely a lot in 2 years. And the organization right now that we put together to kind of be a steward for that has definitely been growing significantly. So it's looking like progress is going to continue forward, hopefully accelerate, and continues.
Oh, well, that's good. You're not trying to promise the moon and do it all next week. A lot of people are very impatient in this space, which really annoys me as an investor, because things take time to build. So it's nice to see that you do have a plan and you're not kind of rushing it and just expecting things to happen instantly. Jetfunk has said, what part of the mining rewards go to the dev funds and ambassador keys, and how will it evolve in the future?
So that's where we get into the foundations of the distributed autonomous communities. So as it stands right now, the developer and ambassador keys are kind of somewhat represented by the Nexus embassy as it stands. Now, they're designed to be distributed, but right now they're hard-coded. So the solution that we found in developing that is to create kind of a distributed voting system based on 6 different voting groups, which would be level 1 trust, level 2 trust, 3 trust, currency, ambassador, and developers, so that if there's, let's say, a new organization that wants to act on behalf of the best interests of Nexus as a whole, they can petition a contract out, and that can be either validated or invalidated by the community. And if it's validated, then the organization is funded. And so if they, let's say, misbehave, then they can be fired, or that can be invalidated at a later time if they don't perform. So you build kind of the foundations of a meritocracy. The developers would be the similar way. You are a developer, you want to work for Nexus, you're hired by the global network independent of your geographic location, just dependent on your merit. So it's going to take a little bit of time to get that right and build some of the foundational elements that's going to require. So that's why that's being reserved for the Obsidian updates. So the idea is that the nonprofit that exists right now is a steward for this to continue to innovate and bring this forward to the point where it will either be dissolved, it'll either be filed. It will continue to have an ambassador contract so that we can create a more purely democratic system, but also allow the network itself to remain sovereign.
Okay, so for your vision to be completely achieved, how expensive do you think it would be, and how many satellites would have to be launched, and how ambitious of a project is this, especially financially, and where's that money coming from? People want to know.
So that's where we get to the ambassador and the developer fund. As I've stated before, it's kind of like a treasury system. So it's going to be fairly ambitious, of course, to get it going. And I mean, part of that, being solved, I guess you can say, is to continue to collaborate with more people, to innovate, but most of all, to build a model in which other people can apply and create revenue from launching their own satellites and give them a formula to do such. Or the same thing with the mesh networks, because the idea is that we shouldn't have to build everything. We should build a set of templates and tools that allow other people to do things and expand upon that. And I think that's really what's going to make this type of vision become true. It's going to require a lot of global participation and a lot of collaboration between people. It's not something that one person could say that they could do. Now, the vision is the vision, and we're doing our part to set the foundations of it in hopes that people continue to work forward as we become maybe more or less relevant.
And I'm sorry if you hit on this already, but do you have any satellites like working right now, like up in the sky? Like, and if you do, like, what are the laws of like around that? I mean, can you just launch them over any country without having any, like, I don't know, permits? I don't know.
Well, so we've got our satellite in manufacturing right now. I mean, we're shooting to have that, in the near future up in orbit. Some of that depends on vector, other technological things too, and getting that developed. There is some challenges with the regulations, especially you have to deal with the ITU, which is the International Telecommunications Union, to kind of own a range of frequencies. And that's another part of building that model for other people. They can launch it under a frequency range that would be owned by public domain. So it is a tricky game. The way we're kind of working with it right now is using UHF, VHF, which is regulated under radio bands, and we can get an experimental license to get operational sooner rather than later. But you definitely, when you deal with it, that kind of have it on a more a country basis. So if you're trying to broadcast over other countries where there's not some license or nonprofit in that country, then you do run into some potential issues. So it's definitely as much a regulation hurdles as technological hurdles to get that moving forward and get that done correctly.
Okay, so it's not like oceans or like the sea law where you can just be so far away and it's okay. It's just like international space. It's like it's different than that. You have way more regulations.
Well, there is a certain height that determines international space, but the thing is, the way they look at it, the governments, is where you launch it from is basically where you're under the jurisdiction of. So you kind of have to deal with that to a certain extent, since there does have to be some form of organization to really make it, I guess you can say, have a physical or a business structure associated with the conventional old system in order to make it something that, let's say, doesn't get taken over by another or regulations come down on you. So yeah, it's a kind of catch-22. I've heard of some people that have launched satellites without a license, and what happened is the launch provider and the actual company that launched the satellite got in trouble for it. So it's kind of tricky too, because some of these regulations are there, constraints, but other ones are there because certain frequencies have certain interference patterns with others. So if you just go up there and start beaming down radio waves, you could be interfering with other signals. And I mean, there's a lot that goes into it. So, there's a level of cooperation that's needed to not step on the toes of anybody that's up there, but to also make something that's more free and open. So it's kind of the challenge is balancing those two things.
So who in what you referenced earlier, like about people getting in trouble, like the companies that actually made the satellites and launched them, like who did they get in trouble with? Was it like the government, or was it?
Yeah, it's generally the government of the country that launched it from. And so the government will usually go after the launch company and the people that actually had the satellite that paid for the launch. I think I heard of it happen in India a while ago. I can't remember the exact off the top of my head, but I do know that has happened. So, I mean, it's not just when you build a rocket too, I mean, you have to deal with the Federal Aviation Administration and everything, especially over in the States. I mean, you can't just launch something up in the sky and expect nobody to come around. So I mean, there's certain things that we have to deal with to get that done properly, and that all kind of ties back into we got to play the game of, I guess, the rules of the world in order to change it. We can't just go in and say this is your home field and we're going to make our before we've established ourselves further and built it out. So the idea is that, you know, the regulations are going to come, they're going to try to stop it, but the ultimate vision is the ultimate vision. And I think it will outlive all the attempts to stop it. But in the present time, in order to make it successful long-term, we have to understand the bounds in which we're working. Otherwise, we could just end up creating something that gets shut down very quickly and never reaches the full fruition of its vision.
Absolutely. Yeah, because I mean, I'm just thinking about places like China and stuff where, I mean, we complain about our internet being like censored and monopolies kind of running everyone's internet connection. But in China, I mean, it's even worse. And it's like, it's horrible. Yeah, it's horrible. So, I mean, it's just weird to think about that because I really like this idea of like complete decentralized internet. I mean, because you can't really have a decentralized cryptocurrency until the internet's decentralized because we're all still under this control. So like for this to work though, it's just there's so many huge hurdles. I mean, in other countries, it's like could this be successful enough for you just operating in like the United States and other countries where you can actually work with the establishment?
Well, I mean, I think for it to work, it has to be global and there has to be enough demand and a movement around it where people start to set, I guess you can say, the precedence of what they're willing to accept. Right now, I mean, people, they can be constrained by different environments. So, I mean, getting to your question about can you do it through just one country, that's not the wisest way. That's why you get which is the International Telecommunications Union. And that's where you really get the internet. So you start to have to deal with international organizations to really get that full global coverage that's going to be required to make this something fulfilling of its intention and vision.
Yeah, I really hope this works out because this is awesome. So let's see, what's the next question? Could governments intervene and block you? Yeah, could government kind of touched on that already? Essentially, yes, right? I mean, governments can intervene and block you, right?
Yeah, if they really want to. Yeah, I mean, you can go the ghost way and try to launch a rocket, but then you have to figure out how to build a rocket out in the middle of nowhere that nobody knows about to do. I mean, so it comes with its challenges. So, I mean, in my perspective, the easiest way is to just deal with the powers that be or were right now until we empower ourselves enough to be able to start calling more of the shots. Until that day, I mean, we got to respect the game. I mean, we don't have a Navy. We don't have an army. And when you really, really look, I mean, there's a lot of power structures right now that exist. And in order to, I guess, make them less and less relevant, that's where part of the beauty of this comes is people coming together, uniting under a single vision and starting to kind of set the standard of what they're willing to accept. And sometimes, you know, people seeing that there's more in the world for them than they thought was possible starts to change those standards. And I think that's really where a lot of power of this vision is going to come to fruition, is when people start bonding together more like that, regardless of their country, and setting some of these precedents in a very peaceful way. And I think that can be done through just rendering a lot of the existing infrastructure obsolete by making better infrastructure and solving problems that maybe even government haven't been able to solve. Including the currencies or the distributed ledger technology. And I mean, in that sense, it's going to make them less and less relevant. But until those days, yes, it is wisest to know the rules of the game you are playing in order to play it correctly.
Right. And I don't think you need an army, honestly. I feel like you have an army, like, I mean, in the sense that like peer-to-peer, you know, is an army. You know, we're more powerful. There's more of us than them, you know, like, I mean, there's definitely that aspect of it. And that's what I like so much about this space. So someone wants to know about what partnerships you have right now.
So we have a partnership with Vector Space Systems. There are satellite, I wouldn't call them satellite manufacturers, but we're going to be working with their Galactic Sky constellation, and they're also providing us launch services for our constellation. Then we have Singularity Net, which, as many of you know, they are focusing on integrating artificial intelligence into a blockchain and creating or I should say artificial general intelligence. There's a big difference. They're basically, that's why it's called AGI. They're trying to make kind of an artificial intelligence or artificial general intelligence marketplace, where you can basically have your agents and you can buy and sell and tokenize that. So we've been exploring some potential uses with them, maybe deploying certain neural nets to develop the trust system, mature that further, maybe helping test our mesh networks. So that one's kind of an open-ended partnership. It's exciting nonetheless. And then the final one is LISP, Location Identifier Separation Protocol. You guys asked about that earlier, developed by Dino Fibonacci, one of the original Cisco engineers. So he's, I'd call him brilliant personally as far as network engineering. He knows everything all the way up, and he, has a lot of history with being one of the guys that actually built the internet as it is. So that's another valuable thing with pursuing the hardwares that we're deploying in the satellites and everything else, is that's a software layer that really helps with that. And there's always more that we're focusing on, and we obviously will announce what we finalize. So the official ones are what I named, but that doesn't mean that we stop there. We're always looking for the best projects to continue to partner with, to create a kind of collaborative approach to things. I could summarize it in a kind of mathematical proof. It's called Metcalfe's law, which states that the value of the telecommunications system is based on the square of its participants. So, I use this to kind of show mathematically how collaboration is far more powerful than competition. If you have, let's say, 4 people competing against 4 people, that's 16 people, or 16 versus 16 if you square it. But if you have 8 people collaborating together, you get 64, which ends up being 4 times the amount. So continue to exponentiate that forward, getting larger and larger groups of people together and creating more of a collaborative spirit, which I think is going to be good for crypto the more it evolves. Since crypto is so hyper competitive, I really like to postulate what it would be like if it was hyper cooperative. I mean, would we be in the same place, or would we be light years ahead? So yeah, a little bit of an non sequitur there, but I think it's important to express that is part of the philosophies that kind of really drive us forward.
That's awesome that you're partnered with Singularity. I love AI. That's like my favorite thing in this space. I'm so excited about it, and different currencies and cryptos coming out with it, using it, different projects. I everyone knows Sophia. It's an awesome project, and it's gotten a lot of attention. How is your project going to utilize AI?
So I was getting into fundamentals of the trust system earlier. You can think of it kind of like, if you don't have some way to measure yourself or measure something, then you have no frame of reference for what relative to that is either good or bad. So when the network starts to be able to learn what it is, right, what normally happens on it, how transactions normally flow, how people work together, then it can start to measure if somebody's coming in as a bad actor. So that's one aspect of it, is kind of forming, I guess you could call it a type of intelligence in the trust system, which would act like a network's immune system that would be able to tell things that are coming in to attack it. And so you'd open up a whole new set of security options associated with that, where one wouldn't just simply be able to come into the network computing power or a bunch of computers or a bunch of resources that are, we could call them physical. You'd actually have to be developing the mathematical track record associated with you and your relationships with other nodes, and they would have relationships with you that would create the foundations of the system knowing itself and being able to detect anything trying to manipulate that consensus, which just further secures the idea of the distributed system.
Okay, and looks like we're wrapping up here soon, but another question came in about energy efficiency and how good is that with the 3-dimensional blockchain system you have planned?
So the first 2 locking levels aren't going to require an incredible amount of computing power. The third lock level will be kind of for mining. So that's going to be kind of a distributed pool. So, that's obviously going to be power, but is not going to rely on the level 3s to be secure. So it kind of, I guess you can say it takes the best of worlds. When you have, I guess you can say, mining integrated with these other types of proof systems, but not one requiring the other, then you open it up to be more energy efficient in the future, operate that way, but still gain some security, and also the useful benefits of mining, such as the distribution method, where you mine coins into existence, backing it by the electrical cost to create it, where it costs close to $1,000 to create 1 Bitcoin now. You create a floor in that respect, and also kind of a requirement to do it, requirement to produce it, and spread that over a long period of time, which I think is one of the more fair distribution methods that can be done in distributed networks thus far. So yeah, the efficiency of it comes from not really relying on that, but utilizing it as effectively as possible. Okay,
well, it looks like you got to answer some questions over at Reddit now. I just want to thank you for answering all of ours, probably for the 50 millionth time. You were great, and I think everyone has a better understanding of it now. And if anyone in here wants to continue this, you can head over to Reddit. And thank you again, Colin.
Thank you.
The main problem with you, Colin, is we can sit here for hours and hours and just keep discussing things. Because the way you talk and come across is just amazing. And today and yesterday, we've been doing lots of research and watching past interviews, and the amount of knowledge you have is just incredible. And I'd like to get you back in the future and do just a more in-depth, deep dive and stuff, because we've kind of skimmed the layer now. So, like, I'd love to do that later down the line, but I'll speak to Anastasia about something like that. But cool. We've set up a Reddit thread at the moment with some more community questions in. So just go and take a break or whatever, and then if you want to answer some of them and add some links, and then more people can get an in-depth answer to some of them.
Cool. Well, thank you for having me on the show. You guys had some great questions, and thank you for the compliment as well. I look forward to potentially doing this again.
Yeah, thank you very much for coming in.
All right, guys. Thank you.
You've been fantastic.
All right. Thank you.
So guys, move on to the Reddit. I'm going to post a link in general now. So if there's any ones that you didn't answer, just pop over there. If you want to answer anything that you've come up from here. So any questions that have come from these discussions, I know I've got a few, so I'm going to chuck them on and just go head on over there and see how that goes.
Cool. See you there.
You love me.